Yeah, here comes the Christmas train. Woo! Yeah, here comes again. Yeah, thanks for watching. You behind the screen, thanks for watching. So we are now on practice test still. We're looking at number 16 next. So this is kind of an evil problem. But we got this, we got this. Try to get a common denominator, eliminate the bottom, solve for the top, solve for the top. So go and try it on your own. Try it on your own first. See how you do. And then push play and see. Try it on your own first. Then pause me. Then push play and see how you did. So the factors of 6 are, of course, x plus 2 and x plus 3. So x plus 3 needs an x plus 2 to the top and bottom, top and bottom. And then x plus 2 needs an x plus 3 to the top and bottom, top and bottom. And now we have a common denominator. Common denominator. So don't forget that our restrictions are, don't forget our restrictions. So our restrictions are x can't equal a -2 and a -3, right? Awesome. Okay, so now we can eliminate the bottom and solve for the top. So we get 5 plus x minus 1 times x plus 3 equals, whoa, we have to seashell twice? Whoa, we have to seashell twice! X times x is x squared. X times 3 is 3x. -1 times x is -1x. -1 times 3 is -3. X times x is x squared. X times 2 is 2x. 6 times x is 6x. And 6 times 2 is 12. So this becomes an 8x. When you combine like terms, combine like terms. On this side, 3x minus 1x is 2x. Combine like terms, combine like terms. And then don't forget the 5. And so 5 with the -3 is a positive 2. Positive 2. Okay, because we combine the 5 and the 3 and it becomes a 2. So then we minus, whoa, we don't have to factor this one because the x squareds are going to cancel. And then we're going to minus 2x to this side. So we get a 6x. And we're going to minus 12 over to this side. And we get a -10. Which is going to be weird because we get 6/10. Which reduces to -5/3. Divided by 2, divided by 2. So x equals -5/3, which is not our restriction. So we're okay, we're okay. We got -5/3. -5/3. Nice. Okay, so now think about these true or false statements. An extraneous solution, right? Extraneous solution, like x equals 2, comes from correct steps, but is not a valid solution because of the restriction, because of the domain. Because of the domain restriction. Because of the domain restriction. Yeah, restriction. Yeah. So yeah, like x can't equal 2. For example, we get a solution to, but it doesn't work. That's a true statement. That's a true statement. To add or subtract rational expressions, you must get a common denominator. That's true. To multiply or divide rational expressions, you must first get a common denominator. That's not true. You just factor the top and bottom. Multiplication's going on, so you can do division then. And just cancel out the top and bottom. So when you are simplifying rational expressions or solving rational equations, the first thing you should do is factor all factorial polynomials in the denominator. Yeah, that's true, way-o. And then listing domain restrictions will help you find extraneous solutions. That is true. That's true. So how do we find the vertical asymptotes and or the horizontal asymptotes or arrows? Well, you factor the bottom first. So pull out an x. We're left with x squared plus 3x minus 10. So we just pulled out a GCF. We pulled out the 3. And now you can factor the bottom. Factor the bottom. And 2 times 5 is 10. Sign of middle term goes with a bigger number. Good. Don't forget the x. Don't forget the x. So what's our vertical asymptotes? Well, it depends. Can anything cancel on the top and the bottom? No. Nope, nope. So nothing can cancel on the top and the bottom. So no holes for this one. No holes for this one. So we have 3. Whoa. We have 3 vertical asymptotes, you guys. So at x equals 0 is a vertical asymptote. X equals 2 and x equals negative 5. So we have 3 vertical asymptotes. So that means that we also have a horizontal. If you have a vertical, you also have a horizontal asymptote too, probably, right? And so then we got to look at the powers. And so our top power, 2x to the first power, dot, dot, dots, over x to the third power, dot, dot, dots. And so we look at the powers. Look at the powers. And so top power is less than bottom. And since top is less than bottom, then we say Bobo. What does Bobo mean? So if it's bigger on the bottom, Bobo. Bigger on bottom. Y equals 0. Y equals 0. So y equals 0 is our horizontal asymptote. Y equals 0 is our horizontal asymptote. Whoa, what if it's bigger on top? What if it's bigger on top then, Mr. Newble? What if it's bigger on top? Well, then you have to divide them. X squared divided by x to the first power, dot, 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 dot. And that's just going to equal x to the first power, which is linear. And since it's positive, it'll have a positive slope. And so it'll be down and then up. Down and then up is our answer for the HA, because there is no HA. So down and then up is the end behavior for this one. Down and then up is the end behavior. But we probably have a hole and not a vertical asymptote. Let's see. So let's go ahead and factor. Let's factor. Let's factor. So x and x. 1 and 1. Plus and plus. Whoa, one of them cancels. So x equals negative 1 is the whole. That's the whole. And so that means we have no vertical asymptotes. And when we have no vertical asymptotes, because there's nothing left on the bottom to be a vertical asymptote, then this is linear, most likely linear. And you look at the end behavior, right? Down to up, down to up. Okay, last one. So nothing cancels on the top and the bottom. We set it equal to 0 to find the vertical asymptote. So we minus 3 to the other side. So we get 2x equals negative 3, and then we divide by 2. And so we get x equals negative 3 halves is the vertical asymptote. And then to find the horizontal, you look at the powers. You look at the powers. Invisible 1, invisible 1. The powers are the same. And since the powers are the same, you just use the numbers in front. So we're going to use 5 halves. So our horizontal asymptote is y equals 5 halves. Right? The horizontal asymptote, y equals 5 halves, or 2.5. Comes from the numbers, comes from the numbers. Nice. Okay, so we're almost done. Let's take a look here. List the information for the rational function. Nice. So they already factored it for you. You'll probably see that on the test as well. Isn't that nice? So they already factored it for you. So the thing that cancels on the top and the bottom, that's the whole. That's the whole. So we get x equals negative 2 for the whole. To find the y value, of the whole, do you remember what you do? To find the y value, you plug in the negative 2 into the reduced function. So where's our reduced function? I don't see it anywhere. Wow. Oh, here it is. Reduced function. So we have left x plus 1 to the third power divided by x minus 3 all squared. So we want to take that negative 2 and we want to plug it in there and there. Plug it in, plug it in. So let's go ahead and plug that in. So we have x plus 1 all cubed over x minus 3 all squared. And we're going to plug in a negative 2 there. So we're going to plug a negative 2 there now. Wherever we see an x, we're going to plug in a negative 2. And so we have negative 2 minus 3, so that's a negative 5 all squared. And then on the top, we have negative 2 plus 1 is a negative 1 to the third power, which is just a negative 1. So we have negative 1 is what that becomes over 25. That's evil. So negative 1 over 25 is our whole. Negative 2 is our x, but negative 1 over 25 is our x value and our y value for our whole. Our restrictions are x can't equal a negative 2 and a 3. Good. The vertical asymptote was ever left, and so that's an x equals 3. And because of the power, it's an even, which means up, up. When you're doing the vertical asymptote, right? It means up, up. Let's see here, the y-intercept. Find the y-intercept, you take the, find the y-intercept, you set x equal to 0. And so whatever's left, the reduced function, and so we have x plus 1 over 3 to the third power, x minus 3 all squared, so you plug in the 0 there. So we're going to plug in a 0 here and a 0 here. So we're left with 1/3 power over negative 3 all squared, which is a positive 9, so 1/9. So our y-intercept is 0, 1/9. Because negative times a negative is a positive. Positive 1/9 is our y-intercept. To find the x-intercept, you set y equal to 0, but you also just set the top equal to 0. And so our x-intercept is going to be y equals 0. You have to set the top equal to 0, which is x plus 1 to the third power equal to 0. And then you cube root both sides. You cube root both sides. So then the third power goes away. You're just left with x plus 1 equals 0. And then you minus 1 to the other side, minus 1 to the other side. So we get x equals negative 1 for x-intercept. So negative 1 comma 0. Now to find the end behavior, do we have a vertical asymptote? We do. We have a vertical asymptote at 3, which means we also have a horizontal. So then we check our powers. We check our powers. And so for the end behavior, we're going to have x to the third power, right? Dot, 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 dots, all over x squared, dot, 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 dots. Oh no! Oh no! Top is greater than bottom. And since top is greater than bottom, top is greater than the bottom. That means we have to divide them. And so that means it's going to be a 3 minus the 2, right? You have the third power over the second power. So those are going to cancel. So you have x to the first power. So it's linear. And linear means that the end behavior is just going to be, is it positive? Yep, it's got a positive slope. So it's going to be down then up. It's going to be down then up. Down then up is our end behavior. End behavior is down then up. All right, you behind the screen, thanks for watching. See you on our next video. Thanks for watching. See you soon. Bye for now.